Hello everyone, my name is Amit Kumar Mahanti. I am an educator at Mentor for you. So in today's class, what we will understand how we will solve this particular question, because this question is a part of a special series which is known as Taylor series. In this Taylor series, what happens? We will try to first write the numerator in terms of denominator, and so that we can separate the two terms. Like there are two terms in the denominator, we will try to find out in terms of 1 by a into b, and we'll write the numerator in terms of b minus a. As a result, what can happen? I can separately write 1 by b minus 1 by a. That is the term of particular Taylor series. So by differentiating or by writing in a different way of 1 by b minus 1 by a, what is the advantage that I'm getting? Since there are many repeating numbers within this particular series from n equals to 1 to n equals to infinite, what we can do in this particular situation here, we can take out all the particular repetitive terms. Since we have written this in a particular of 1 by b minus 1 by a, what we can see is that there are many repeating terms in summation of 1 by b and in summation of 1 by a. So since 1 by b minus 1 by a, all the repeating terms that is present in terms of b and in a will get cancel each other, and as a result, with the sum of infinite series, I will be able to reduce this series in summation of few numbers or few terms, and this is how the particular question is solved. So let's go to the particular question and answer section and try to solve this particular question. Clear? So now, let's first understand how we'll write this particular question. So it is given summation of n equals to 1 from n to n equals to infinite n by n to the power 4 plus 4. So what is the first thing that comes into our mind is we have to write the denominator in terms of somehow the numerator. But here what is happening? There is a large disparity in the power of the numerator and the denominator. So what I can write? Can I look into how to update this value? So I'm keeping the summation asset so that we can keep on freely calculating the values. Okay. So n by, can I write n to the power 4 as n square whole square plus 4 as 2 square? Yes, I can write in a particular way. Now, what is this formula? This is a square plus b square. What is the new form? A square plus b square formula? It is a plus b whole square minus 2ab. I can write the a plus b whole square in that particular term. So it will be how much? N by. So in this particular question, what is our a? N square and b is 2. So it is a plus b whole square. So it is a plus b whole square minus 2 is how much? 2 into a is n square and b is 2. So minus 2n whole square. Yes. So 2ab will be how much? 2a is how much? N square, and b is also 2. So it will be 4n square. 4n square can be written in terms of 2n square also. So I have written it directly that way. Clear? Now in this updated form, what is happening? This is a square and this is b square. A square minus b square. See, if I update the value, how will it look like? It will look like something like this. A square minus b square is a plus b into a minus b. So it will be n by n square plus 2 plus 2n into n square. A square minus b square, a plus b into a minus b. Now we have written our summation till this way. Now, what is the next thing that we need to understand in this particular way is that we have brought the particular summation into form of 1k into a into b. Correct? Now we need to write the k in terms of b and a. So that, let's say if I write the k as b minus a somehow. Yes, if I write this k as b minus a, and this is something like this. So if I write in a differentiating manner, it will be how much? 1 b by a into b minus a by a into b. As a result, a and a will cancel, b and b will get cancelled. Ultimately, I will left with 1 by b 1 by a minus 1 by b. This is the target. This is my target. So that what is happening? My ultimate summation can be divided into two parts. Here, that is my goal. So that all the particular common summations that are present between a and b should get cancelled. Clear? That is my goal. So keeping that thing in our mind, let's come back to our particular question. So if I look into this particular term, let this term be a and this term be b. What is a minus b? Let's first go through. So if I try to write a minus b, what is happening? A is how much? N square plus 2 plus 2n and minus of b. So minus n square minus 2 plus 2n. Correct? This is how this minus will go. So if I add it up, it is the values are getting cancelled, and ultimately we are remaining with 4n. Clear? Now, with this remaining value of 4n, what I can understand is that ultimately I have the value as n in my numerator. If I would have had 4n, what I would have done, I would have written this 4n in terms of a minus b, which is the in terms of denominator. Clear? Now, so what is my goal? I need to multiply 4 in the numerator. So to balance it out, what I'm doing, I'm keeping a 4 in the outside, 1 by 4. So now this is the perfect, our original term. Now let's go to the next page and try to proceed with this particular summation. So if I'm going to the next page, what is happening? It is, let's write the value. It is 1 by 4 multiplied by 4n by n square plus 2 plus 2n and n square plus 2 minus 2n. Clear? Now, if I try to update this particular value in a more different way, it will look something like this. 1 by 4 n square plus 2 plus 2n minus n square plus 2 minus 2n. Yes, you can see this is the particular form. Sorry, 2n multiplied by n square plus 2 minus 2n. Now, in this particular situation, you can see if I solve this, it will come out 4n. So I have written that particular way. So if I try to, so it is how much? B minus A by A into B. This is the same format that I have written there. Now, if I solve it out, if I update it, how will it look like? It will look something like 1 by A minus 1 by B. So in this situation, if I update the value, it will look something like 1 by 4 into n square plus 2n. This particular term will get cancelled with this, or I am remaining with n square plus 2 minus 2n and subtracted by 1 by n square plus 2 plus 2n. Clear? This is the value that I am remaining with. Okay, now let's go to the next step. So before proceeding to the next step, what I can see, can I write this particular situation in 1 by n square plus 2n, n square minus 2n minus 2, and this is written as 1 by n square plus 2n plus 2. So I have just reassembled, or you can say reorganized the particular question. Clear? Let's go to the next page. So what I have, whatever values I have till now, so it is somewhere between 1 by 4 multiplied by, let's check with the value. It is 1 by 2n plus 2. So 1 by n square plus 2n minus 2 minus 1 by n square plus 2n plus 2. Clear? I hope up till this it is clear. Now, how will I update this particular value? Can I write it as 1 by 4 or 1 by n plus 1 whole square? Sorry, n minus 1 whole square minus 1, and this will be 1 by. So sorry for that. Whatever wrong that is particular done in this particular question, it will be minus 2n plus 2, so that I can have n minus 1 whole square. What is n minus 1 whole square? N square minus 2n plus 1. So as a result, what is happening? N minus 1 whole square plus 1. That value is remaining. And what is the next term in this situation? It will be n plus 1 whole square. So it will be n plus 1 whole square plus 1. Clear? Yes. So if I write this particular value in terms of summation, it is n equals to 1 from n equals to infinite. 1 by 4 into n minus 1 whole square plus 1 minus n plus 1 whole square plus 1. So you can see what is happening here. So if I say this is the first term, this is the n plus. So if this is n minus 1 is the first term, if I add 2 to it, it is becoming n minus 1 plus 2. It is becoming how much? N plus 1. Or I can say this is the, if this is the first term, this is the third term. Clearly. So from here, what I can see, if I apply the n equals to 1 here, what I can understand. So for n equals to 1, let's apply the value. So it is 1 by 4 multiplied by. So for n equals to 1, it will be 0 square plus 1 by 1. Yes, minus 1 by n equals to 1 will be 1 plus 1, which is 2 square plus 1. Clear? Now for n equals, add it up with how much value? For n equals to 2, so 1 by 4 into multiplied by n equals to 2 will be 1 by 1 square plus 1 minus 1 by n plus 1, which is n equals to 2 for this. So 2 plus 1 will be 3 square plus 1. Clear? Next value will be, what will we look like the next value? The next value, let's go to the next page so we can write all the values here. So what is happening? What are the previous value? We have 1 by 4, 1 by 0 square plus 1 minus 1 by 2 square plus 1. Correct? This is our first term. If I proceed with the next n value, it is becoming 1 plus 1 by 4, 1 by n equals to 1, n equals to 2. So 2 minus 1 will be 1 square plus 1 minus 1 by 3 square plus 1. You can see what is happening here. Plus 1 by 4. Here it is the change. 2 square plus 1 and minus 1 by 4 square plus 1. And let's write another value, 1 by 4, 1 by 3 square plus 1 minus 1 by 5 square plus 1. So you can see this first term doesn't have anything common. But as I'm going to the second term, this particular term is in positive, yes, and this term is in negative. Clear? So you can see the same value, it is present in positive as well as negative in the same sum. So as a result, what is happening? All the repetitive term will get cancelled. So you can see this particular term will get cancelled with this. Yes, and the next term will get cancelled with this. In the similar way, if I try to next value, these terms will get cancelled with this. So as a result, what is happening? This initial terms are remaining as it is. You can see this term and this term. Yes, these two terms are remaining. All of the rest of the terms are getting cancelled with each other. And since all the starting two terms are remaining, the last two terms will also be remaining. So in our situation, what is happening? Which are the last two terms will be remaining? It will look something like this. So the last two term will lie on this particular side, on the negative side. So it will be how much? Minus 1 by, for n equals to infinite, it will be n minus 1 whole square plus 1. And another term will be minus 1 by n square plus 1. Clear? These are the second last term. Now, if in the second term, what is the value of n? N is infinite here. And this is infinity minus 1. And this will be infinite. This is the value of n correctly. Now, if I apply the n as infinity here, what is happening? It is 1 by infinity minus 1 whole square. It is, and the next term is 1 by infinity plus 1 whole square. Since the bases are infinity, what is happening? 1 by infinity is 0. So this term will be 0. And for infinity also, this term will be also 0. Clear? So for n minus 1 terms and nth term, the output is 0. Clear? Now, if I come to the first value, so which are the two values that are remaining here? This value and this value. If I add it up, what are the values? So the first value is 1 by 4 into 1. And the second value is 1 by 4 into 1 by 4 plus 1 plus 1 by 4 into 1 by 1 by 2. So ultimate value is 1 by 4 plus, you can see what is happening. Next term is 1 by 8. If I try to take the 8 as LCM, so it is 2 plus 1, which is 3 by 8. Clear? So the answer is 3 by 8. I hope you are able to understand. So how did we solve this particular question? First, you can see if I go back to it, what did we did? We first tried to, what is our goal? Our goal was to write the denominator in terms of numerator. So for that, we needed to make some adjustment. So first, what did we did? We divided n to the power 4 plus 4 in terms of a square plus b square. Then I did it terms in terms a plus b whole square minus 2ab. Now, this 2ab is written in terms of new particular term, which is a square minus b square. A square minus b square is a plus b, you can see, and a minus b. Up till this is clear. Now, when I am doing like subtracting b with a, what I am getting is this particular situation, which is 4n. Clear? So in the numerator, how much value do I have? I have only n. So to like balance the value, I'm multiplying 4 on the numerator and the denominator. Clear? Now, when I'm proceeding forward, what is happening? So this is the particular term we have arrived till now. Now, this particular 4n I have written in terms of denominator, or you can say this is our situation. B minus a into b. If I solve it up, it is becoming 1 by a minus 1 by b, because it is b by a into b minus a by a into b. So a is getting cancelled, b is getting cancelled. So b and b getting cancelled. So 1 by a minus 1 by b. Clear? In that particular way, we have written this particular term, which is 1 by a minus 1 by b. Now, we have written till this. Let's go to the next solution. Next part. Now, I have updated this new particular part in terms of 1 by n minus 1 whole square plus 1 minus 1 by n plus 1 whole square. Clear? Just I have reorganized and written in particular way. So what I have happened here, I have written this whole term, which is summation, in terms of 1 by b minus 1 by a. Why I have written in terms of subtraction of one particular term to the next term? That we will discuss in the next process, next step. So here, when I'm starting to put the value for n equals to 1, it will look 1 by n minus 1 whole square plus 1. So n is how? N minus 1. N is 1. So 1 minus 1 is 0. So 1 by 0 square plus 1 minus 1 by n plus 1 whole square. It is 2 square plus 1. If I'm putting up, I'm slowly putting all the values. What is happening? You can see. As I'm proceeding forward, this new term that I'm taking across is 1 by 2 to the power square plus 1. This particular term was what? In the negative in the first. Yes, and this term is now in the first direction. Or I can say, if I'm writing in a particular way, if I go to the previous method, what is happening? If this is the first term, this is the third term, correct? So it is written in terms of first term minus third term, correct? Yes. Now, next situation, it is second term minus fourth term. Yes, fourth. Now, next will be third term minus fifth term, and next will be fourth term minus sixth term. So in this situation, what is happening? The third term and third term was initially one in negative. Now it is itself in positive. This fourth term and fourth term was initially negative. Now it is in positive. As a result, what will happen? All of this particular number will get cancelled with each other, and ultimately, what will remain? The starting two values will remain, and the ending two values in this particular side will remain. Because what is happening? This is in particular way fifth, and this will be 7. Fifth will get cancelled with 7. As a result, the first two and the last two will remain. So if I'm going to calculate for the last two values, what I'm getting, it will be 1 by how much? If I go back to here, what is happening? You can see 1 by n minus 1 whole square plus 1 by n square plus 1 whole square. These two value will remain, and the first two value, which are 1 by 4 in this situation, 1 by this particular value and this particular term. Clear? Now, in this in the last two particular terms here, if I'm applying the n as infinite here, what is I'm getting? 1 by infinite square, which is 0, because the infinity is in denominator, and in the next term also the infinity is in denominator. As a result, what is happening? The last two terms are 0, so this is getting 0 and 0. And what are the value of first two terms? The first term, it is 1 by 4, and the second term is 1 by 8. So 1 by 4 plus 1 by 8, I'm getting the ultimate value as 3 by 8, and our answer is 3 by 8 is the answer for this particular question. I hope this was clear. So if you're able to understand, and if you want more particular explanation on such topics, you can let me know in the chats, or if you want, you can book a class with us. Our email will be on the particular below the video. It is mentorforyou2024@gmail.com. So yeah, thank you. Take care. Remain safe. And if you want to access the PDF of this particular question along with the solution, you can access in the like in the description. I will be leaving a PDF link. So the particular PDF, so you can access it. So yeah, that's all from my side. Thank you. Take care, and we will meet in the next class.